Hello everybody, welcome. How are we all doing? Um, so, oh, Akra's my friend. Thank you so much for this, I appreciate it. How you been? Oh yeah. Hello, smiley face. Yeah. How's things going, Akras? How you been? Hope you're having a good holiday season, I guess. Um, but yeah, since last stream, I have done a little bit more work on this shader, basically. So what I want to do is I want to go over the like, because last stream I really struggled to really understand the problem enough. So I was just sort of writing code to try and understand the problem. But now I've written more code. I understand the problem a lot more. And I think a lot of these comments don't probably make too much sense either, to be honest. It's just me writing out stuff, just trying to make sense of it all. And I'm going to have to rewrite a whole bunch of it anyway this stream. So, what we're trying to solve, right, is trying to make like a 3D volume. So we'll just draw a 2D volume because it maps to the same thing. Where there's basically going to be 1024 going across, so it's a 3D volume of 1024 cubed, right? So if you try and fit that into memory, what is that? It's 1 gigabyte. So obviously we can't have 1 gigabyte in memory for every model. That's just ridiculous. So we've got to get around this problem. And still alive, awesome. Yeah, I had a 3 days or until the 8th January. Nice time off. I've been off since last week, and I've got until the 2nd of January. So I literally got 2 more weeks, or less than 2 weeks now, because I'm at the end of today. So yeah, counting down the days until I go back to work, but it's good. Just been shopping, chilling, hanging out with some of my friends. Yesterday, I don't know, a couple of days ago now, we went out and did some crazy golf and throwing axes, and they got destroyed. So it's all good. So did some more Christmas shopping today. Got a couple of bits. Still like 2 more to do, and then I'm all done. But yeah, other than that, just seeing family and just chilling basically. All gonna be good. So so yeah. So yeah, we basically have a 3D volume, essentially. This is the maximum volume. Maybe we can have an infinite volume, a bit like how this is some infinite canvas, right, that we can draw on. But I don't know how, sure, it'd be more freeing for people using the tooling, but I don't know how much of a technical ball ache it would be, right? So we'll just start off with a fixed volume, a fixed restriction, and we'll go from there. We can probably make it dynamic, but we'll see. So basically we fill in a 3D volume with spheres, right? That's the basic idea. And you have 1024 going up, down, left, right, back, front. Right, so 3D volume to 1024 cubed space. So how we solve this problem, considering stuff could be... Sorry, these damn headphones. Okay, that was bad now. Right, so you nudge the cable when it disconnected it, and you have to sort of fuss with the settings. We're back. Computers. Okay, anyway, hopefully that stops now. Yeah, so basically what 3D volume, how we solve the problem is two things we solve, right? When you have two sort of spheres next to each other, or not two, a 2 by 2 by 2, we replace it with a larger sphere. Basically. So you have lower LODs. So you basically like wait. Take that back. When you have it kind of works this way. It's a little bit right. Essentially, things are made into 2 by 2s by 2 by 2, 2 by 2 by 2s, basically. And when you have a 2 by 2, so let's just imagine this one is one of those 2 by 2 by 2s. When you have one which is surrounded by another load of 2 by 2s, we can actually replace that with a bigger sphere, thus reducing it down from 8 spheres to 1 sphere. And you can do this at many levels of detail. Because as this one gets bunched up with another 8 of its spheres, we can reduce that into a smaller one. So essentially we can reduce the amount of volume. We can cover the same amount of volume with less spheres, as long as it's completely filled space. Right, so when you have the detail on the surface of the model, shall we say, right? That's one thing that we do. And the other thing that we want to try and do as well is imagine you're only filling this space where you don't need memory for the rest of the space. So the way we solve that is we have a tree structure. So we're doing essentially the tree structure is is a 2 by 2 by 2, so we're just going to draw it as 2 by 2 for this example. So imagine this is L0. This is the lowest level of detail of a model. But then you can have L1, which is essentially a group. It's basically 16 spheres. Yes, right. In this example, but it would be 8 times 4 for 3D. So you've got yourself one box, another box, another box, and essentially each of these is a zoomed in level for each of these spheres, right? This one could probably be that guy. This one can be that guy, and this one can be that guy, right? So they're just a zoomed in level of those spheres, providing more detail. And you have another level which basically does zoomed in level for all of these, and it explodes exponentially, right? So this is how we cover that big volume, because simply if you don't have anything down this quarter of the 1024 cubes volume, well, you won't have that sphere there, you won't have this whole thing here and the whole descending or descendants of that, right? So that's another way how we save volume or save space in a volume like this. So now we just got to construct to try wireless audio. Yeah, maybe that could work. I've got I don't know, I've got like a whole setup and everything. I should really get I should really try and improve it at some point, to be honest. Probably get better sound quality. Yeah, maybe. So basically we've got to build this tree. The input is basically just a bunch of operations that it took to build the shape, because if it was to store this all in memory, even in a tree structure form, it would take basically hundreds of megabytes, anywhere from 50 megabytes ish for some small model, all the way up to probably 1 gigabyte or more, or into the gigabytes. So basically compress this information into a bunch of like basic shape operations that you use to sort of paint and build this list of spheres, right? And then we just got to construct that into a tree. So I've been kind of construct that into this sort of tree, right? So I think my initial idea of going down from level 0, like constructing level 0 first, going over all the edits, then constructing all the nodes in level 1 and going over all the edits and seeing if they touch any of those is probably a good strategy. But the biggest problem is when you get down to, or is the simplification step. When you get down to level 10 or 9, right, which is the 10th level, you're dealing in stuff in this with this these dimensions, right? 1024 cubed, and as we said, that was 1 gigabyte. Oh yeah, hey there, so how's it going? So this would mean for the game would need 1 gigabyte of video memory or more than 1 gigabyte of GPU memory, probably gigabytes of memory to even build one of these trees, which is crazy. So because you basically have to build, like, if you have to reserve for the worst case, and if you just to fill this volume with a bunch of these little spheres, you would have more than 1 gigabyte, because it's 1 giga spheres, right? So whatever the number of bytes per sphere that we need is, yes, multiples of 1 gig. So that's not good. So basically, I don't really have a way of getting around that problem. I've been thinking about it for the past few days, and the best solution I could come up with right now, I've gone over tons of iterations. I've been thinking about bit fields to reduce it down to 256 meg or something like that and do a pre-pass, but there's not a good solution out there that I can think of at the moment. So the best solution I've got is that we just restrict this number and just do it in steps. So you know, if we do, if we basically have a volume, the maximum volume that someone could build, which is 1024 by 1024, by 1024, right? That would mean that we can just build it in simply 8 512 cubed volumes. And you can just build them one after the other, and you'll just basically be using, so you would you partly build the volume, simplify that, and then partly build this volume, heavily simplify it, and then partly build the next volume, heavily simplify that, and then when you do the simplification step, you're obviously bringing back more memory for the next volume build to happen. So that's what I think we're going to work towards, is that sort of solution. And with this solution, we could probably get away with an infinite size for a volume, really, or a near infinite size for a volume. But I don't know, again, how much of a programming problem that could be. But that's just my thoughts on that. 1 giga, Chad. Yeah, 1 giga. Okay. To have a static structure in mind. Yes, we're just using an octree. So that's what we've got it programmed at right now. We've just gone octree. Yeah, so we've got a thing called a volume. So this is like a model, right? But a sort of, it's not really a model, it's like a piece of a model. It's just a 3D volume where all the spheres go. And we build this cluster tree, and we can also build a BVH as well for this volume as well. So where is it? Oh no, this is the data version, the one saved out to disk. Yeah, so just got some cluster node thing, and it's basically just every node has 8 spheres, right? But it also can have 8 children, basically. And the reason why it has spheres and children is because when we produce the lower LODs of the highest level of detail model, we will need spheres to exist there anyway. For further away renders, right? So yeah, so the initial shader I've got is this sort of construct leaf spheres. So I'm thinking, so we've got to do the whole, yeah, so we dispatch LOD count number of construct leaf spheres for, yes, this one just constructs the leaf spheres, so it basically goes down the tree one LOD at a time. And I've written this shader a little bit weird, and we're going to correct that today. So it does one LOD one at a time, so we do 10 dispatches. They're synchronized, so only one runs at a time. So it'll start on L0, right, level 0, which will just be one node. It will do all of those. I might be able to change this to a 2, that'll be better, I think. Because then there'll be 32, basically. 4 times 4 times 2. Then there'll be wave 32. We can guarantee that. So yeah, it goes from low to high. Runs over a list of edits, then constructs. Yeah, I might do that whole... Yes, it runs over the list of edits and constructs the initial tree of leaf spheres. But I didn't... Yeah, we're doing a LOD one at a time. We can account for these guys. It's already doing it one at a time though, is it? No, we'll get rid of that. It doesn't make any sense. Ignore that. Right, so I think we want to yeah, so these are things that we need in addition to these leaf spheres. We need the lower level of detail spheres of the tree generated. We need to remove any excess allocations, and we need a contiguous array of leaf nodes. So when we do our LOD selection, when we try and render these things, they need to be quick. So we need to start them off at the leaf nodes and go up. So I think I might do this in a 2-phase thing, where it has a pair of shaders. And it might be like a volume. I think it's called like I had a name for one. It's called refine LOD. So when it does one level of detail, it goes over all of those. We'll write out an array of nodes that it made that can be simplified, and then it will simplify those. Right. Okay. Hey there, Cat Payne. How's it going? How you been? Okay, so let's just get into this shader. So it's basically starting from the root. And the reason why we start from the root and not from the bottom. So we'll always start from the L0 and branch out from here. So we see if the edits affect this level 0, because when you paint your spheres down, you can target a specific level of detail when you want to paint it. And you can have it yeah, but you're very unlikely to do level 0 because it's basically a 2x2x2, but you never know, right? So the reason why I start at L0 is because we're going, if we partially construct the tree, it's the only possible way to sort of find the space in which, say if you've triggered this space to build here, right? This quarter to build here, and you've got these guys. Well, to attach it to the tree, the best way to attach it to the tree is literally to start from the top of the tree and traverse down it and find your node. Find where the node goes, right? So that's the reason why we go top down. Thank you. Thank you, Dory. Doing good, just living life, struggling with sleep a bit. Fair play. Yeah, I've been on and off of sleep past few days because of kind of went out late, and I've been catching up with a baby as well, you know. But I'm kind of getting there. You just got a have you just got a racing mind when you try and go to bed or something? Right. Oh, I need something to prop my phone up a bit. Let's go over there. Cool. So basically, I've done the. So we go over all the edits. So, right, let's take a step back. Each thread gets a sphere inside a cluster, and a cluster is a 2x2x2. We've kind of got. What is this? So it's a 4x4x2. So it's we've got 4 clusters here, right? Yeah, we've got 4 clusters here. Now we can't go any lower than this number. But yeah, the reason why a cluster is a 2x2x2 is because you can replace that nicely with just a single sphere. So the basic idea is we've got to find the cluster that we're going to be inserted into, and then like from there just run over all the edits. For some reason when I initially wrote this, I didn't think about it in that way. So we get this coordinate at the construction LOD, right? Then that's the one. So on the first LOD, it's just going to be basically 0 to 1 inclusively across each dimension. So you need to find. So we basically need. Yeah, I think I was trying to overcomplicate it initially and see if I could save, or if I could build the LOD. If I could build the lower level of detail, like if I could simplify while I build it going down the tree. That's what I was trying to solve, but it's impossible. So if you have a group of 2x2x2, you can simplify it with a single sphere. I was seeing if I can simplify that while going down the LOD tree to save memory, but it's impossible. So we basically need a system. We go over all the LODs, and we need to So let's take this add one. Oh my days, this is complicated. Okay, let's take that with us and simplify it. Yeah, I tend to get excited about something, then slowly throw my sleep out of work. Fair play. I get you. Yeah, just gotta learn to shut off, you know, or get distracted by something else, which is boring, you know, and then just go to sleep. Yeah, exactly. Damn trees. Sure we got this though. So we got a construct LOD, so what we're constructing starts off as 0. So we're going to traverse down the tree until we find that the node basically. So, alright, let's get this right. Get rid of that. Edit. We're not any edits at this point. So we're just trying to find the node in which that we have a sphere in. That's what we're looking for. So we're just going to trust. So this is the root node, right? Start at the root node, and we're simply just going to index and get our node. So what are we looking at trying to do here? Chord in LOD. Child index. So we just figure out how to traverse down the tree. So it's less than the construct LOD, therefore we just want to keep traversing towards it. Wait, what is this doing? Then this one is the code where it says, without the LOD we're constructing, this means either create a new node or we've reached to put the sphere into. Right, so we want to keep some of this. So this one means we simply traverse the tree. Oh, right, okay. Stop as there is a lower LOD sphere that is present. Right, so if the edit doesn't have an overwrite lower level of detail, so you might have explicitly painted down a level of detail 1, and so that's a massive sphere, and then you've got a lower level of detail, sorry, a high level of detail sphere which is smaller, and you've painted sort of over that sphere, and you've said basically you want to preserve the preserve the lower level of detail edits. So I think you just want to keep note. Stop here as there is a lower level of detail edit. Yeah, I think you just might want to keep note as you traverse down the tree. Is there a lower level of detail edit that's in the way of this one? Or something like that. Is that a way of... There's a sphere present. Let me think about that. Stop here as there is a lower sphere. So if you traverse down the tree and you come across a sphere, and to find your node, like, so you would have done in a previous dispatch, you would have done that lower level of detail, and then it generated a sphere there. That means everything after that is probably doesn't matter. Does that? Shall we say? Yeah, I think we could say it doesn't matter. Leaf sphere exists at child. Stop here as we're trying to... Now, once they just stop here as there was a leaf sphere placed at a lower LOD. So painting any further. So it's kind of an optimization. Will just be a waste. Will just be a waste and removed. Well, it's not even that. It's a painting further. Yeah, painting further does not make any sense whatsoever because right, I'm back. Damn thing. Cable's a bit shoddy or something. I don't know. But yeah, so you've already painted the leaf sphere down, which then means that you've basically, you shouldn't be able to paint a leaf on a leaf, right? It doesn't make any. You shouldn't be able to have a like it is a leaf node, basically. So then this one's saying, yeah, I guess we kind of want to make this a GPU warning thing, I think, as well, to sort of warn if we encounter some problems. That'd be kind of cool. I haven't got this yet, but we should do it. So this one is saying stop here as a future edit. Yeah, this is to do with the edits. So we've got to get rid of this because we're outside of the edit scope. This simply traverses to the child node. Where did that node index come from? Here. Good. Okay, so this is before you're at the construct LOD. So when you're on LOD 0, when you construct an LOD 0, never come into here. But it'll come to here. So this one is saying either construct a new node, a child node if we haven't reached the child LOD. So this was only possible when we was doing the edits, right? So I think we should just get rid of all this code because we done it in the add code anyway, or the remove, yeah, in the add code when you evaluate one of those edits. So I think you just want to go up to the construct LOD and get rid of this, and then move all this in. So here we're just simply trying to find that cluster node that we are supposed to belong to, basically. And if we reach some place where there's a problem, we'll just return, right? And just get out of here, and that's it done. So this is the ideal thing, an ideal place to hit, because it will save a whole ton of work. So it could be a good speed improvement as well, which is good. So this whole block of code here is to simply traverse down the tree. Traverse down the, it's just an octree, right? So write down the octree, and find the cluster that this thread is so you're targeting like a sphere in the thread. So we could say traverse down the octree and find the class that this thread is inspecting a sphere, or not really inspecting, is traverse on the octree and find the class that this thread is calculating a sort of an eighth of, maybe. Whether or not a traverse down the tree, the oak tree, to find the cluster. This thread is calculating whether or not a sphere exists in it. Something like that will do. So this whole comment doesn't need to exist. It doesn't make any sense. So that is basically where we're going to find the node we're going to target, right? So now when we've found the node we're going to contribute to, and we should really know the child index here. In LOD. Where's the... There's another one. Okay, I guess we just need that, a copy of that. Right, so this would just be a child index at, not in LOD, at construct LOD. So that will get us our child index, which is going to be useful. So this basically is our sphere index, right? Inside that octree node. So we go over all the edits, pick up our edit, we get our center position, our half dimensions, we get our rotation. Now, this code is more complicated than it needs to be. I was basically trying to see if I could simplify while I go down one LOD at a time. It is possible if the edit itself is massive and it has absolutely tons of spheres inside of it that you could make higher level of details for. Completely possible to do that, but it just adds more code complication, probably makes the whole process a lot slower, and it doesn't really fully solve the problem. For the majority of the case, where you're probably down at the highest level, one of the highest level of details, and painting down some groups of spheres with a brush which is probably a little bit bigger. So I think we just want to get this back to a simple state. So we're going to have to do that. Target LOD is just the edit targets, and we're simply saying, oh well, you've painted down this thing which is like very big, and you know, you could really just say it's a lower level of detail or something rather than this high level of detail paint. But yeah, it's not a really good idea. So we still need the rotated. Let's just get this right. So this thing needs to get replaced with construct. What is this? So do we need to offset by some kind of I think it is 0.5 still. Whoa. Hey, there exists. Thank you so much for the sub. Look at 9-month streak. Thank you so much. Appreciate it. Happy holidays to you. How you doing? Claus, you honeys. Hello, how's it going? How you doing? Welcome to the stream. Fresh H2O. So basically, let's just get this right, and then I'll go over what this does. I think we could just mutate half dims here. It's nothing. We don't need a for loop. This is terrible. Alright, let's heavily simplify this. So what we're going to do if we're outside the shape... Yeah, we still need that there, get rid of all this. Right, I think we're back to some level of, you know, simplified version. So basically, right, we've got an edit. It can either be an ellipsoid or a cuboid. And so they're basically both defined as a center position and a half dimensions. And they have a rotation. So it can be an axis line bounded box that's rotated. So it's not axis line, so it's an actual cuboid. And then an ellipsoid as well. So basically what we're doing is we're getting the sample point, which is the coord at the highest LOD. So that's our grid coordinate in the... Wait, it's the highest LOD? Yes, it is. Oh. Wait, I think I needed the other code back. Maybe I need that comment there. Okay, so you say you've got this low level of detail. So you've got your... Imagine you've got like the level 0. And you've basically got an octree, right? Where each sphere goes into, right? Bum, 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 bum. So what we're trying to say is if your edit sort of goes over this cell, well, we want to put a sphere here, right? So what we're trying to do is you've got your index for this guy, for this guy, and it ends up probably here in space coordinate, in 3D space coordinates. So imagine this is level 0. So you've got like, this is 0, 0. Oh, no, it'd probably end up here actually, wouldn't it? Okay, no. Yeah, 0, 0. And this will just be 1 to the right, 0. Yeah, bottom left, origin. Okay. So basically, like this is like, but this is the lowest level of detail. So at the highest level of detail, this is actually going to be 1024 cubed. Right, so when you expand this bugger all the way out, it's going to exponentially grow each level of detail going downwards, right? Because each one of these spheres is going to have another group of spheres and so on and so forth. And that's going to subdivide down 10 levels and be ultra small and have 1024 cubes, which is about 1 gigaspheres, basically, right? There's quite a lot of data. So what we need to do is these coordinates are in highest level of detail space, right? So we need to move this from... we need to use our coordinate in highest level of detail space, right? And then we need to... So that's one thing, which we've got here in the highest level of detail space. And then the other problem is we actually, because our position's here, well, this edit that we did, this ellipsoid edit that we did, wouldn't have quite triggered this to be placed because the coordinates here. So we need to offset that by half a grid cell size in at the current level of detail, right? So this is 0.5, right, multiplied by what it takes to go from the construct LOD to the highest level of detail. So what power of 2 that is. Is that right? Let's think about that. So if you're at LOD 0 and you go up to 9, it's 1 shift left 9. then half of that. We've got to double check this. It might be off. I thought this. You doing alright? Yeah, not doing bad, my friend. Not doing bad. Just been catching up on sleep, chilling, Christmas shopping, and trying to think about this problem and how we can solve it the best way. And yeah, definitely been exploring a ton of areas in my mind. But yeah, I think we got something that we can build, test out. Hopefully, it's fast enough, and extend it from there. So yeah, we're just gonna dealing with crazy tree structures, those things. But yeah, things are good. Been off work for a week. Got like less than 2 weeks till I go back now, so just gonna be enjoying that time off and relaxing, and hopefully get something on the screen when it comes to this sort of new LOD cluster stuff that we're doing. So what is this number going to be, right? So you get the calculator open. So the number that we need is actually a quarter. It's probably actually a quarter, because so this is going to be basically, it's got a width of 2. So you basically want to get the it's got a width of 2. You want to get that sort of quarter offset into the center of your sphere. Yeah, so if we have, let's get out one of those programming calculators. 1 shift left 9, 512. See, it wasn't quite right, was it? Right, I don't think this is right. What about the coordinates as well? So the construct LOD be 0, and they'll go towards 9. I think you do need to do that. You say if you've got 1. Oh no, it might be. No, that is right. That's right. Because it would be 512. 1 shift left 9. We get to 512. That'd be. Yeah. That is right. That is right. Because if you have this coordinate here, this is just 1. But if you shift it down to the highest level of detail, it will be 512. Because 512 is half of 1024, which is where this one would be. So that makes sense. Just double check this one is right then. So you're going to get 512, and you're going to times that by 0.5. So that'll give you 256. So if you offset this by 256 across the 3 dimensions, that'll get you there, which is a quarter of 1024. Boom. So it's good. I like it. Yeah, so you get this LOD grid cell half dims. So you offset. Yeah, so all you're doing is you're offsetting it into this thing here. And then we're going to extend. So this works, but then what happens if your, edit was only down here? Technically, it's gone over this cell. So it should have, it's gone over this grid cell. So it should really make a sphere here, but it won't because it's not inside this point. And we're doing a point versus ellipsoid or axis line bounded box test. So what we do is we actually extend see, we just want to know if we've actually hit it or not. So I think a lot of this could just go into here. And we just want to mutate that. And we just want to rotate the... Yeah, rotate coordinate. Yeah, so we just extend the half dimensions by half of this grid cell size. So this would basically push this into being this or something like that. And then it will go over the point, and then we just know it's inside it, and that's all we want to know. And if we are inside, where is it? If we're outside of the shape, we want to continue to the next edit. And we just don't bother processing this edit at all. Okay. Very good. I think we could just... Oh yeah, that'd be fine, I think. Right. High Z chain. I'm not sure what that is. Sounds very familiar though. I don't mean by... Sounds familiar. I just need to know exactly what you're saying. Right. Hierarchical depth buffers. Yeah, I was thinking it might be something like that. Like a depth pyramid. But no, this is... We're trying to build a 3D volume of spheres, basically. That's what we're doing. But we're trying to build it as a tree. So we save the space, the empty space, and other things as well, like, again, levels of detail. So when you do an add operation, so yeah, it starts off as a list of edits, and we're trying to decompress it from these edits into a tree. So this is where we used to go down the tree. Okay, so there's a few things we've really got to be careful about, and that is we've got a couple of options in here. Overwrites. So we've got this sort of overwrite low and overwrite higher. It's a pretty cool idea. I think it's gonna be quite... I can use it in a very artistic way. So the idea is if you see each edit, you'll be painting down spheres with like a brush, and you'll be targeting a certain level of detail. You can go from about 0 to 9 inclusively. So if you're painting it down to 5, you might not want to overwrite any of the higher level of detail or lower level of detail stuff. Like, you might want to paint down some big objects, but not get rid of the really high level of detail stuff, or the other way around. You might have some very high level of detail, like big spheres, basically. Sorry, low level detail, some big spheres, and you want to get the high level of detail, like the small brush, and just sort of paint around it. And you don't want to sort of make the objects disappear. That are towards the lower level of detail of the tree, right? So we're just going to make sure that those things are respected, is all. But we can heavily simplify this probably. So you're at the construct LOD. So yeah, this for loop's going to go. A lot of this stuff is going to go. I just want to make sure I'm not deleting some stuff I don't need. Stop here, as the future edit will be overwriting a higher level of detail edit with a lower level of detail sphere at this child node. Right, I think this is where we've just literally got to... Right, so you're at some constructs level of detail, you got an edit. You wouldn't have gone past the tree if there's a sphere there already. So you would have solved... Yeah, so basically if you come across anything that paints past you, is that right? Yeah, I think let's just rewrite it rather than delete anything. Let's just like go, okay, screw all this. We'll use it as something to double check from. So basically, we've got a thing where the edit operation has a target level of detail, and if this thing is basically there's a few, it could either be less than the construct LOD, and in that case, we probably just want to ignore it, right? So I think in a lot of cases, like, wait, is that right? Oh no, because it could overwrite. It could overwrite you. Yeah. So if this is less than the LOD that we are constructing, then there's a case where this is where we're inside the shape, and so we're adding here. So if the edit overwrites lower, so in this case we want a higher level of detail because we are the one that we're constructing is a higher level of detail. So in this case, we are simply going to so write a comment down. So this is going to say we're going to remove our sphere. So remove our sphere as a lower level of detail brush. Sphere has sort of brushed over us or something, right? With edit dot overwrite enabled or something like that, right? So that's something. So yeah, we're just going to write out some sort of skeleton code and we'll simplify it. And we might have to share. We might be able to share some of this with the remove operation as well, because there's an add and remove op. So there's that. Right. There's another one where the edit operation, the one that the target LOD that we're painting down is higher than our construct, the one that we're currently constructing, which means we don't want to be, we don't want to put any sphere down because, like it's just not the LOD that's been requested, right? And obviously, if it can simplify, it will simplify it in a later stage. So this one means we want to make sure that we definitely have some form of node down. So this one would be like, like basically say we need a child node. So sort of note down that we need a child node, like, note down that we need a child node. Will we need to remove anything? Wait, it could be higher, and it says, wait, we've got to be careful here. So if there's already a sphere down, and then you've painted something down, options. There you go, look at the options. So if edit dot overwrite lower. So we overwrite lower. Okay, this is where it gets a little bit complicated, but yeah. So if we have something which overwrites the lower level of details, which means us, because we're lower, let's think about this one. So, yeah, I think it's pretty simple. We basically need to say, you know, Boolean has leaf sphere or something like that. Leaf sphere exists at child, something like this. Given the current node, like, I don't know if this is what we're going to actually be doing. We'll put dot 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 here because it's the old code was made with a certain thing in mind, but we're simplifying it even further. So I think there's a better way to do that. So if a leaf sphere exists at the child, so if it doesn't exist at the child, wait. If overwrite lower or this does not exist at the child. Then we note down that we need a child node because we're not going to have anything in the way at this point. Yeah. Note down that we need a child node allocated by the end of this threads. By the end of this invocation or something like that. How do you spell these things? Invocation. It's just one N. Okay, good. Yeah. So, okay. So going back to this one, this would also need to sort of mark. So unmark the child node needing to be allocated. So we don't need it in this case because there would have been something at a low level of detail which is going to be the leaf node. So anything that comes at a higher level will no longer be a leaf. Okay, so does this have to do anything with the right? So we also want to remove our sphere as a higher level of detail has brushed over us with the lower enabled. Ooh, that should stay higher. Okay, so the final one is when the construct LOD is equal to the target LOD, which means you basically just place down the this one here is you want to essentially place the sphere down, right? So you place the sphere down, and when you're placing the sphere down, you also want to unmark the child node needing to be allocated, right? Because I am a leaf sphere, right? Basically, this is a leaf sphere. Okay. And that should basically be the logic, and I very much overcomplicated it before because I was trying to do so much while I was constructing the tree, and I was hoping to save memory, but I've realized it's probably impossible to do that, so we can heavily simplify it now. And I think we can do it something like this. So let me just double check. See, I wonder if the remove could borrow a lot from this, and the branch, we can have less branching, so that'd be amazing. Right, so again, this is just the horrible code. Let me just double check, is there anything? So I was doing stuff with this, remove edit indices. Yeah, all of this crap can go as well. I think we can just get rid of it all. Right. I think I might just fish this out and stick it in a section somewhere. Just in case I want it back, but probably not. Excuse me. Right, stop that craziness there. So I want the remove thing. Right, here we go. Put a break in there, because if not, bad things happen. So... Oh. One more of them boys, there we go. Okay, so... Right, so if you were to do a remove, right, like... I guess it's a more simplified version of this. And I'll double check the ad in a minute. Yeah, I think we'll complete the skeleton code and then we'll just double check it all. And then we should be able to see how much of this we can get implemented, get up and running today, hopefully. We'll see. So the remove, you're painting down to remove, right? You've got a target LOD that you're painting down. If you have a target LOD that is less, like if it's less than or equal to, no, sorry, if it's less than and you've got to overwrite higher LOD, we're going to remove the sphere. It's the same thing. Then we unmark the child needing to be allocated at this point. Is that right? Yeah. It's interesting. A lot of it could probably be shared, except for like when you go to hit, like, right. So this logic's a bit different. So when you've got you're painting down that's higher than your current construct, you are essentially, you don't need this leaf check. Okay, so I think this, like, it's kind of good that this is shared because it means we can basically put this in an if statement and sort of do it separate to this switch, maybe. Because I think all of the threads are going to share the same, are going to go the same way, basically, and it'll save doing it. All this extra branching, I reckon. So that is fine. This one is saying a release for exists at this child. And if we're in the lower hierarchy. We don't want this check if it's an add or if it's a remove. We just want to blanket remove it. Like we just want to blanket remove. So I guess, right, we could, right, just do this. Just do those and heavily simplify. Or equal data volume add and not that. And then this could just be basically, oh, place down your sphere. And this one can be like, oh, basically just, you know, remove the leaf sphere. And do you also want to unmark any child needing to? That is very true. What do you want to do in that case? Oh, okay. You only want to do this one, providing that you don't have a. Oh. I think there might be a bit of a. Right, so what about the case when you've got a higher level of detail than the one you're currently constructing? You've gone and painted that down over where this place is. Right, so you know it goes in this cell somewhere. Yes, you know it goes in this cell somewhere, but it happens later on. And then you come along and you've got something where you say, hey, by the way, don't overwrite anything that happens later. Well, we need one of those arrays in there, or jot down. So I guess this is the case, right? See, I guess you simply won't know. Oh, could this be a problem? So this case happens, right, where you've got this lower level of detail, so it's more smaller. And you've got and that's been painted down in this area. But obviously it gets constructed later in a future dispatch properly. So if you were to do this add, realistically you want to say if the edit dot overwrite if there's not an overwrite higher. Or if it's overwrite higher. Or there isn't anything that's actually been placed down at a high level of detail here that exists. But you don't know if it exists yet. Because it could have been placed down, then removed. And you simply don't know because the list of edits hasn't ran yet. Okay, so this is for a case when there is a lower LOD. Right, let's get this if statement thing all sorted out for a minute. And it wants to possibly preserve the high level of detail. See, maybe we only have it as a one-way thing, right? Because I don't know if it's possible. Maybe we remove this, the ability to preserve higher level of details, because I don't think it's possible, because you don't know if it's been painted down yet. So we'll just have a way to preserve the lower level of details, I think, when you're painting down, which is probably what it's going to mostly get used for. Maybe, I don't know, I can see it being used both ways though. Is there a way to solve that one? Like, because you could have put any form of, so if we draw this out, it'll be easier to understand. Like, this obviously subdivides down like crazy, right? Let's just do that justice. Into many levels of detail. And you could have put a little edit and just painted over here, and that would have, but when you're constructing like this level of detail, you don't know whether something got painted down here and then it simply just got removed in the future, right? That little piece there, or it could still exist. Like, you simply don't know when you're constructing the higher level of detail. So it's basically Okay, so could you then do a partial thing that you then correct later? Because we're not doing it. We're not solving all problems here, are we? So maybe what we do is we just go, okay, we'll just place a leaf sphere here, but there could be a more leafier leaf, if that's the way you want to say it. But then you kind of have to know, like, which one overwrites which. No. Right. Yeah. See, while I was solving this, the way I was trying to solve this problem last time is that I had an array, and I jotted down the edit index in which this happened at. So you could jot down, you could be like, oh, by the way, that node, where it got that sphere is from this edit. And I just have to jot down the overwrite higher thing as well. Yeah, I think it's kind of possible to add, but it's kind of a bit fiddly. And I think for now, just for first implementation, let's just not add this overwrite higher supporting, because it's a bit fiddly. But we'll definitely to do handle overwrite higher here properly. It's a bit fiddly. Anyway, so we're just going to place down our place down the sphere down. Right. Okay, remove sphere. Good. So at the end of the shader, all we want to do is, I think we just want to, so if we want to, you know, if, so there'll be a little marker where we basically say, you know, child, allocate child node. If that's equal to true, you allocate that. And then we probably want to have, if we have any spheres, we want to construct, we probably want to say like spheres count. If that's like non-zero, we also want to allocate an array of spheres for the node, basically. So we'll have them probably in some form of LDS, I think. I think they'll fit in there just fine. So I think that's basically the skeleton of the shader that we want to write out. So we'll go over it again, and this time we'll build it, I think. Right. So this is like by doing it on that time we're able to count for the following. Maybe not. No. No. Okay, let's just get rid of that comment. The shader is a lot more simple, so I don't think we need the comments too much. But yeah, we'll put them in as necessary. So traverse down the octree and find the cluster that this thread is calculating whether or not a sphere exists in. Owns this, you know, owns a sort of owns 1/8 of yeah, this is where a sphere or child node should be placed, something like that. So this is the child node index. Okay, we should probably be a little more granular with this. Right, so the allocation strategy could simply be bump allocating a lot of this. Yeah, we can bump allocate these things, which should be good. I think we'll take that to the end. should be able to bump allocate those or something like that. We'll see about that in a bit. The volume. So start the root, traverse the tree until you find the cluster. This is fine. Calculate the child index to traverse down the... Right, so the leaf sphere exists at child, this way we can skip. LOD has been placed. Yeah, see, this is where if we have that overwrite higher, this sort of optimization, if you will, might not be able to exist. So you'd have to traverse down, run over all the edits for those lowers, see if you have something, and then possibly at the future when we sort of refine it and go back up the tree, we have to sort of get rid of that leaf, which is that second leaf node that happened too early or something like that. But yeah, so jot a comment down. Warning, to achieve edit.overwrite higher, this optimization will not be possible, I think. So I don't think this would be a warning. I think this one would be a, you know, so basically we would have wait a minute. Where's the edit thing that I was looking at? So the edit's lower. If it's lower and you've got overwrite higher, remove the child because it's no longer needed, right? Bit questionable. Yeah, I'm not sure what I was thinking though. Right, so the child node, if that's not even allocated, so there's no children. Same time you make a child is here, when there's something that goes further. But it could have possibly been removed because we was told to remove it by the end of it. Okay. See, if you say overwrite if edit.overwrite high level of detail, then remove Do you just want to unmark? Right, but if that is not set, then you don't want to remove. Hey there, Danzy, how's it going? Merry Christmas to you. How's things been? You got all that Christmas shopping done? Right, so maybe we do just support this higher thing. Yeah, okay, so if we delete this, so we'll just simply say if the children nodes do not exist, it's like, you know, stop here as we removed, as like, you know, as when this sort of node yeah, but it could be that a child doesn't exist in the oh, it's in the spheres thing, isn't it? Damn it. I just need some bits. I need like 8 bits. It doesn't need to exist anyway. We need a bit set somewhere. Needs to be atomic though. And it's all made. Can all be made at the end. Probably use ballot or something like that. Need a ballot instruction. So that could probably be 24 and then 8. No, you need 3 bits. Well, no, sorry, you need 8 bits, sorry. Yeah, you need a bit, so 1 for each child. Was mom extra prep? Owing to the family health, but otherwise doing okay. Fair play. No, not to worry. But yeah, it's quite expensive doing all the Christmas shop, you know. Yeah, good. You're not doing bad. Just yeah, trying to save for our holiday in February, going to Australia, but also trying to get people gifts and stuff at the same time. So just been doing some shopping, but also it's mainly just chilling and looking after the baby. I've been off for the past week, so it's been really nice. Been super good. Let's not pack that yet. I think we might need it to be atomic. I really don't like having a bit set here though. Right, so you never managed to fully reach the node. So up here is when this sort of node was constructed, the child node was deleted by an edit operation. So we don't need to So we don't need to process this cluster, basically. This cluster or group of clusters. Or its this cluster or its ancestors or descendants. Oh, I can never spell this word. A's and E's all over the place. Descendants. Ah, words. Descendants. Okay, got it. So, so we've got the child index, we go over all the edits, fish out the edit information. Oh. If we're inside, you know, if the painting shape just touches the grid cell, we're like, this is fine, we keep going, and we then basically make some of these edits. So we need to basically have a list of, we have a count of spheres, we need to have the sphere information stored somewhere, and we need to have a boolean, right? So we need like a few things. So spheres count, this would just be in some VGPR. So one, wait. No. You can have that shared between, then you need an atomic. Then you need an atomic. Yeah, it's still fine. My phone's just playing up. Oh, my phone's Wi-Fi is disconnected. What bugger? Yeah, so basically we need some thread group memory, that stuff. You know, that good stuff. Why is my Wi-Fi not on my phone? Does this sometimes. So dispatch group. So we're gonna make ourselves a, let's just call it the what is it? It's the volume cluster tree construct leaf spheres. What are we gonna call this thing? It's a no, that's not a good idea. Oh, LDS, that's what we'll call it. There we go. After the AMD naming of it, right? Local data storage. Something like that. My phone is disconnected. What about hosted? Why in the middle of a stream did you do? Okay, I'm just gonna restart my phone and see if that'll fix it up. In the meantime, I'll just see if chat responds every now and then. Right. So basically we need, so this thing is launching, so our clusters are 2 by 2 by 2, but the minimum amount of threads you really want to, or the minimum amount of threads you run in lockstep is 30. Okay, the minimum amount of threads you can run is 32 because 32 threads run in lockstep. So to do some kind of 3D volume space, 4 by 4 by 2 is kind of the minimal amount. So thinking about it from that regard, we've got so you've got an arc tree of 2 by 2 by 2s. You know, 2 by 2 by 2 is a cluster. you've essentially got 4 clusters, right? Yeah, you've got 4 clusters per you got 4 clusters that are running, and then you've got 32. Is that right? Yeah, 4 clusters running, because 4 times 8 spheres per cluster is 32. Perfect. So essentially what we need to store in this LDS volume is, and this is terrible naming. Maybe I should find a way to make this better, but yeah. Like maybe these could just be inside the scope of the function, but then they're kind of shared between functions sometimes. Anyway, terrible. Yes, it's going to be that bad. Maybe we can make that short somehow. So anyway, let's just put the data in here. So we basically need 4 clusters. Right, so you want your the spheres count for each cluster. Counts. Right, we want 1 for each cluster. And then you also want to have all of the spheres for every cluster as well. So in here you need a volume sphere, and these are going to be, so you index first by the cluster, then you index by the number of spheres per or inside the cluster, or which sphere you want inside the cluster, right? 8 spheres in each cluster, right? I think that's basically what you want. So I'm not sure why. Like, I guess I could shorten that, but it's just gonna be a bit silly. Right, my phone's restarted. Hopefully I can get chat back open on my phone. Cannot get IP address. Why does it do this? It's used on my router sometimes. Because it just disconnects my phone, and only my phone, like everything else runs on it. Just fine. Oh well, that's gone in the water. Right, so what are we trying to solve now? So I guess we can shorten the name. Basically it's LDS for tree construct. Leaf spheres. Right, the other question we have, right? The other question that we have is, do we have enough memory? How much memory is this? That's a good point. Just double check quick. These are 8 bytes, right? Yeah, they're 8 bytes because all the bit fields in that. $19 bits unused. Yeah, so that's 8 bytes per node. So you got 8 times calculator. Good buddy, old pal, the calculator. So 4 times 4 is 16. Right, so what's 16 plus 8 times 4 times 8 plus 16. Right. So 272 bytes. Is that enough for LDS? That's quite small, isn't it? So that's per dispatch group. So I think that's fine because you have about 10 per compute unit. Work group processor. The 128 KB. Signifying okay, all 4 SIMD. Yeah, so if you got 128K, that's plenty. Right, if we times it by 10, because it can hold up to, it can switch between 10 different shaders. So it needs to pre-allocate 10 of those. So that's only 2K, so that's plenty. So that'll be good. So that should be enough memory for me there. I hate how long this name is, but oh well. So basically, we've got these sphere counts. These are uninitialized memory when you boot this boy up. So what we need is something known as a cluster index. So this is what we'll be using to access those arrays. So the cluster index, how do we get that? So if we get our dispatch local index, that will give us a number. So we just want to find, we want to say, okay, if, I think we want to do that sort of Z. Okay, the Z one doesn't matter, because I only got one depth basically, but the Y times 4 plus, is it plus 4? Times 2 plus whatever the X is, right? Because you've got 4. So if this goes from, oh no, mod 2, is that right? Was it divided by 2? Plus this divided by 2 is something like that. So your local is going to be an index of this. So 0 to 1. When you divide that 0, 1 by 2, you'll get 0, right? So when you go past 1 and land on 2, you'll get 1 back. So this will then need to be a further times by 2. And then, no, you want the truncating, so you have to divide by 2 times 2. No, you want the truncate of that. So that'll give you either a 0 or 1. Right, so in this case, you probably just want to do a greater than op, right? Maybe. Like if it's greater than 1, then add. No. You need the times 2 in there. Yeah, then plus. Yeah, that's it. That's your cluster index flattened out. So this will just get you basically 0 to 4, or 0 to 3. Something like that. Because you've got 4 clusters, right? Okay. So basically when you start this guy up, you also want to know like, am I, like what is my, so you got your child index, that's here. Yeah, this is quite useful. But you know the child index with easier information, I think. You don't need it at the highest. Like the child index, this is going to be known as cluster sphere index. So this one would just be probably the mod of 2 Oh, no, no, no. Oh, yeah. Mod 2 times 4 on the Z. On the Y, mod 2 times 2 plus SV dispatch local. Oh. So this is basically a 3D 0 to 1 3-dimensional, right? Oh no, it's not. Sorry, 0 to 8. 0 to 7 inclusively. So you're doing, so if your Z, yeah, you're going over, you'll be either start at 0, if your Z is, you know, even, you'll start at 0, if it's odd, you'll start at 4. If your Y is even, it will start at 0, start at 2, and then if your X is even, start at 0, start at 1. And that will get you your, that flattens out that, right? So that means we get rid of this child index and replace it with this cluster sphere thing. Did we never use that? Right, we didn't use that. That's all yet. Okay, we're good. So we got that. We also need to keep track of the number of, or does this thread need a, it's called alloc child node, won't it? Staff is false. So that's just one per thread. Wait. You want that one per cluster? No, one per thread. Yeah. One per thread. So, radio. So it's got to plug all this in now. So you're going over all the edits. You've painted over some grid cell where a sphere could go, or a child node. If your target, the one that we're painting, is lower than the construct LOD, and we're told to overwrite the higher, then remove the sphere. Oh, that's what I wanted to do. We need to initialize things. If initialize LDS, right, and you won't be overwriting anything. So this means that I am the first. Oh. Yeah, let me just do that here right away. So initialize LDS. Should it right away? Yeah, we need to initialize LDS right away. So this has to be initialized in a thread-safe manner because you have multiple threads accessing the same memory, yada yada yada. So you need to say spheres count, and then use that cluster index. This will just initialize to 0. We have, you know, that's a good thing. Spheres counts, mind you. Then this one is, see, really, I think we could just make this an array of 4, right? 1 for each cluster. I don't think it matters Yeah, that just makes it a lot easier to read and understand, really. I think that's better. And that way yeah, should be easier. Should be better. Okay, so you got that. The other one is the spheres themselves. The spheres themselves, they also need to be initialized to something. Now you do have 8 threads, like 1 for each sphere. So we could just go cluster sphere index dot, and then you just initialize it. So how do I want to initialize this thing? So as long as we set the radius to 0, then we know it's not it's garbage, basically, right? So we just set that to 0, it's garbage. Initialize LDS. That's what this section is. Cool. Radio. So getting back to where we were. Now you've got this so going over all the edits, we see over inside the shape. And we're painting down something with a lower level of detail than the node that we're constructing. So if we overwrite the higher level of detail, in this case, we need to remove the sphere. So to do that, we literally just need the perfect. We literally just need this, and that is removing it. As the lower level is brushed over with that enabled. Perfect. Then we literally just go, okay, by the way, allocate child node equal false. You know, and you can say again, we don't need a child node. As the lower LOD or this has brushed over us, right? Boom. So delete that. So that's the first one. So if you don't have this set, it's basically a no op on us, right? This information can be preserved. Then this one is saying if this is if we target if the brush is targeting a high level of detail, which means a smaller sphere, from the one that we're constructing. And this one, so this one is saying like we want to remove like we want to remove our leaf sphere if one exists. We want to remove our leaf sphere if one exists. But we also want to know that a leaf sphere actually exists here. So you can just do this. Right, leaf sphere does not exist at child, because we not it anyway. Damn it. Copied it rather than pasting over it. Okay. So if we have if we override the lower LOD, meaning us, the one that we're constructing, or it's an add operation and a sphere doesn't exist here yet, Oh, it's interesting. I think this could be problematic for... Yeah, this could be problematic because it's going to keep it here. Yeah, this could be problematic for this case here when we've got it so this to-do handle the overwrite higher properly. This could be problematic for this one. But anyway, let's just write it in and then we'll come back over that one. Remove our sphere as hard to do as brushed over with the overwrite lower enabled. Then this one is saying that we want to allocate we need a child node as the higher LOD leaf sphere has brushed over us with this overwrite. Not even with this overwrite lower, but it's just brushed over us in general. Yeah, I think this preserves stuff, this overwrite stuff where it preserves high level spheres, and that might be a bit difficult. We'll see. It might need to get done in a second pass. Would that just make it easier? So you just place down spheres, and then you ought to know where it came from and what you had. Right, let's just keep going. So this is the problematic one, right? So ideally, if you're adding, this is when you're painting down on the construct LOD or anything else. So we're constructing this level of detail and we're painting down on this level of detail for this edit that we're processing. So you should be able to just place a sphere down, but the problem comes where if you have an overwrite higher level of detail, or if you say don't overwrite the higher level of detail, you would place a sphere that you don't know if it's done yet because you're processing the lower level of details first. And it's not done yet. So what we do see yeah, I'm starting to think this is not possible to do. But let's just see if I can think about a way to solve it. If it's not possible with a way to solve it, we could just remove them. Even though it would be cool to keep them. Yeah, if they're not really possible, then we just can't have them. So yeah, if you have this sort of overwrite higher level of detail, if that's not on, and there is a sphere, or is it this one? And there's a sphere, so you're like processing this level of detail, so this big guy here. But as you go down to the higher level of details, they get smaller, and there's actually a little sphere here that's colored in, and you don't want to overwrite that one. But you don't know it's actually there yet. You know that some stuff got painted there, but it could have got removed technically. So the only way to know is if you keep both of them and you just do some rather unoptimized you know, where you just sort of do all of them and keep all the spheres in there, then you do a second pass, where you have to kind of know in a separate array somewhere when this sphere got added, and when it got added, you have to traverse up or down the tree from the top or bottom, and know basically to have the information known of like when it got added, and what did it have the overwrite higher or lower on it, and then you can sort of probably traverse that through the tree in a second pass. That's a lot of fiddly work to do. I think, you know what, if we need it, we'll add it later, but for now we just need to get something working. And it did kind of sound cool, and something like I do really want, or like I do want. But then again, if you just have undo, you know, you paint down, oh crap, I buggered that up, undo, right? You just do a bit of a fine art touch, rather than having something which stops you from overwriting certain data. If we really need that, we can add it in later. But for now, let's just remove it. And that means we can nearly make room for this guy and pack it hard. So that's interesting. Let me get that back to 16 bytes. Right, I think this is fine. So all this overwrite crap that we've got on here, let's just get rid of it from existence. By default, it's enabled, right? Overwrite is enabled. So overwrites it. Goodbye. Then that also means we can bring back that optimization that we had. The optimization was what again? Sorry. If it has a sphere. So can I just undo all of that? There's an optimization that we did. This one. So speed programming. Whoa. Anyway. Right. If a leaf exists here, yeah, so some nice optimization there, to be honest. You can guarantee that the other ones will not exist. Rightio. Nearly there now. So simplified. Now you just got to place the sphere down. Awesome. So basically you just do a load of this. We don't need a child node as the lower LOD, no, as this. Oh, I need to remove that comment. As the, as this is the leaf sphere, right? So we've got these overwrite whatever's in here. We know where to place the sphere down. Awesome. So let's get all these sorted out. So let's find this one. So these are all the bugs that we need. Be quite easy. So the radius of the sphere and the center position and that. Right, it's fixed point. It's in fixed point. Yeah, no, it's fixed point. No, it's not fixed point. Oh, no, 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 no. Right. So whatever the, this is dispatch index, isn't it? Coordinate at construct LOD. So that's all this is going to be. So we center position dot x. I'll repeat that a few times. Like that. So the radius is simply whatever the radius. Like what is that? So in that case, we had that number. LOD grid cell half dims. This can be just known as radius as well. So we can call this LOD sphere radius. And we'll just stick that at the top here. The compiler will sort all that out. So LOD sphere radius, when we set the sphere. What else we got? A material palette material index. That comes from the edit thing, doesn't it? Oh yeah. So we've got this sort of add remove paint color metalness roughness thing. But this doesn't. Does it store enough of the information in here? Like we need enough for a single value. Damn it, I want to fit it into 16 bytes, but I don't think it's going to happen. We've probably got to reduce the rotation down. Something. Yeah, I've got to take bits from the rotation. And we could probably. Like, we can take. We need 9 bits. If we take 9 bits off that, it should be possible. That would be ideal. Although the half dimensions doesn't need that either. Yeah, something like that. But for now, we probably like what do we want to? What do we need again? Right, we need the material index, paint color roughness. Right, I think you just want to have it paint op. Like, alright, so think about this. So paint operation. Do we need paint? Oh, yeah, you're not going to edit the current structure. You're just simply going to paint across all the levels of details and stuff like that. You're just going to brush over a material thing. So you just need you need 4 bits. That's all you need is 4 bits. Material palette, material index. That comes from edit.that. Also generate LOD. Is false. And then there's 19 unused bits we can use for some other stuff. Okay, so that's placing down a sphere. Oh, we didn't add a number, did we? So we're going to do we're meant to be increasing and decreasing with atomics. Atomic add E32. The address of spheres count by 1. Okay. So you definitely know you're adding one there, but you might not be, actually. Like, you only know if... Thank you for the follow. Appreciate it. Welcome, welcome. How you doing? Yeah, so we just want to add 1, basically, if it's new. But when these guys remove it... Okay, I was just thinking as well, like, if you got that paint operation, it's gonna be separate. Okay. Anyway, yeah. So you only really want to remove it if it exists. Oh, I just realized that's 10 bits. Sorry, that's a floating point number being assigned to here. Whoopsie. Radius is... Alright, what does that even mean? Like, you're basically just... You need a number up to 10. So, given a LOD index, like you can know based on the LOD, basically. 0 to 9. Data LOD count, LOD count inclusively. So it's just LOD. LOD would be BC construct LOD. Yeah, you can work out the radius from that. Okay. So back to where we were. We need to decrement. Decrement by 1. Same with this one here. Oh, okay. So we decrement 1 if it exists. Okay, we're getting close. This one says remove sphere, and then you want to unmark. So if you're painting down to remove. Here, and you're at the construct LOD. Right, so if you're painting down remove, you got target size. Are you removing... Yeah, so we could make it not overwrite the lower levels of detail by default. You have to explicitly remove those. That's something that's still possible. Like you're brushing, and that's just always on by default. Where'd the music go? Okay, so when you got a remove brush, you're painting on a certain, you're trying to remove from a certain level of detail. What does that even mean now we've not got that overwrite higher and lower bits? So when you've got a lower level of detail, you obviously don't want to make this brush delete any of that. That would just be crazy. It would just, would it? So a target LOD really only makes sense for when you're adding. When you're removing a target level of detail, it doesn't make any sense anymore without those options. Unless we had unless we made it that it never deleted the lower levels of detail. If it deleted the lower levels of detail, oh yeah, if it didn't delete the lower levels of detail, then it means we could just delete from this level of detail down to the highest level of details, like the really small guys. And you're using that as a way to, or you can just target a specific one when you delete, but that would just take all day. Wait a minute. So if you've got remove and you don't specify a level of detail, what are you deleting? You're deleting the whole thing? Like anything that you touch. So if you have this, the lowest level of detail, which would just be a 2x2x2, and this would be bloody massive. And as soon as you just sort of touch it, and you might be working down this very, very small LOD space or whatever when you've just been adding stuff, and you delete something, and you just want to delete like yes, this overwrite higher thing is kind of useful for the remove. Because you want to kind of know which way. Like you could just target a specific level of detail and you're just brushing over that one to remove. And then maybe you want to affect all of them. Yeah, for now I'm just going to make it target the current level of detail. We'll fix it up when we actually make some tools that allows us to like edit things. Yeah, this, it needs some more time in the oven, it needs some more thought. So for this one, we just want to go, okay, at the construct level of detail. the edit LOD is the same as a construct level of detail. You just want to simply say, and then because you've removed it at this level of detail, you don't want to unmark the child in this case. Remove the sphere as the remove brush. Has brushed over our relief sphere. Then we subtract. Bam! There we go. So that's basically all the code, doing all the edit operations for this cell. We just got to wire to these bits now at the end, which is basically saying, hey, if you have any spheres. So if we are, so we only really want to do this if we are, we're the first thread in the cluster, and this cluster has spheres. Then we want to allocate a, so I got to find my, so no longer do we have this thing called scratch, because it's not that complicated anymore. Volume spheres, no, I don't need any of those. We basically need to bump allocate. Different volume spheres, yeah. So what do we need to, so right, we need an allocator for this. And I was thinking it'd be like a bump allocator, but I don't know if that's going to be possible because we need to have stuff removed. So I think we'll do just we might do a linked list, and it will just bump allocate if it's not got a linked list. So we basically need in the global graphics thing, we need we basically need a free list. We've got unused, so we could just literally use the remaining bits, or probably because you allocate a cluster at a time or something like that, and this could be the memory. Hey there, Sleepy Mushroom, how's it going? Apologies, my phone's oh, it's got internet now, so I can actually put the chat there. Are we going strong with that OpenGL tutorial recommended? Abandoned Blast, sweet, awesome. Is that the learnopengl.com? Very cool. Glad to hear. Have you got yourself a triangle? Or have you got more triangles? 2 triangles? So I reckon 10, 10, 10, 3, so it's 33, 37, 38. 26, I'm way off there, I just removed a whole bunch. Right, so given 26 bits, that's the biggest number we've got. Maybe we're gonna have more things. But yeah, I think we'll give this one the we'll call it the free list next index. And you kind of only need one of these to have it. Yeah, and then in our globals data structure, oh damn, it's a quick fix menu. Yeah, we basically want to have our volume clusters, volume sphere, free list, spheres free list, head index. So this would be initialized to something sensible like and our frame initializer. Well, no, we upload it. Yeah, we upload it every frame. So we'll initialize that to something sensible. Let's just find it in the... So if it's equal to U32 max, we are just going to bump allocate volume, spheres, count, and we'll probably have a capacity in there as well. So that'll just be a spheres cap, which we've got to change that. Oh, wait. This would be spheres cap, this would be 0. So just bump allocate it if not. Yeah, so we just want to have a way to like allocate those. So in the shader, we'll literally just like go, oh, if global? Yeah, that's right. If global, then you access the global. If that is... Now this is an atomic. So atomic, well, yes, it needs to be atomic. So that's across multiple threads, right? So you need to say atomic load. And notice how we're only doing this like once at the end of the shader. And one thread's doing it. So we want to like minimize the amount of times we're sort of hitting this thing at the same time. Because when you hit this thing, it's going to probably be it's definitely going to be a problem because you'll have different compute units that are going to have cache which is out of sync. So it's going to have to flush that or reload that from the main memory basically, or some other higher level cache or whatever. Depends how the system works. I can show you my progress. Sweet, let's take a gander. Okay, I'm not signed in. Cool. Right, so you've got some OpenGL basic cube. Nice. And then you've gone and done a rotating plane. So you started off with 3D, that's good. Oh yeah. Good job. You made it much further than most people. So you got like a rotating plane, awesome. And rotating cubes, the next step. So you've done some texturing on that cube instead of just colors. Yeah. I took a while to go to 3D because the maths really confused me for a while, but I'm getting there now. I did some lighting as well. Look at you go, you got cameras. Awesome. Good job. Got your little light box. Pew. Sweet. Ship it. Good job there, Sleep Mushroom. So if this one's equal to U32 mat, if it's sounds exhausting. It is a lot of work, but at the end of the day, you only really need to do what you need to do to make the game, right? So if you're just making a 2D game that has 3D elements, that's a lot more simple. If you lots of things like that. Hey, Coffee Lava, thank you for the raid, appreciate it. How did stream go? Welcome raiders, how are we doing? We're currently knee deep in some shader code. We're doing some 3D volume that we're filling with spheres, and we're trying to make it go fast and not destroy my memory. So yeah, we're just getting to the new end of the shader. We're just doing some free list allocator for a bunch of spheres. It's just quick and easy. But yeah, how does string go, Coffee Lava? Working on a texture header file system to create texture loading. Yeah, this is why you kind of want to prototype your game ideas and then just sort of know exactly what you want to build and build it. We are doing some graphics. With this project, we are doing some graphics research and development. With basically, can you just render a metric ton of spheres and just have everything made out of spheres and can it look good? And so I'm kind of playing around with that first, and then I'll go do a session of prototyping for a game idea, and then from there it'll just be basically do the features I need to get that game done type of thing. But yeah, it is very easy to overcomplicate 3D. Yeah, put it that way, especially when you're using your own engine. Well, I guess. Is the shader code written in C as well? Yeah. So this is the shader code here. Yeah, I got a custom C compiler that compiles C to SPIR-V. So it just basically means we can share functions and structures across the CPU and GPU, which is super sweet. So yeah, we just so we're able to write some quite complicated code because we can just share massive data structures between CPU and GPU no problem, which is good. But yeah, most engines just need some way of doing that easily. If not, it's an absolute pain. Like just sharing data, but also sharing functions is nice. Yeah, we're just using compute shaders. I don't know if I have anything that runs. No, validation error. But yeah, we got a little test scene where we got a bunch of. All right, when else to stop? I got a VOD I can show. We just got a test scene with a couple of instances rendering. Here's past me. Past me is going to take us on a tour. What we have. Here it is. Eh. No. Yeah, so just got like a couple of renderers that just ray trace against a bunch of spheres. This isn't tons of spheres, so we're trying to make it scale to absolutely tons of them. So it's we're in design. Yeah, awesome. Good. No worries. The Golf engine I'm thinking of is making is centered around a PCG content workflow. Don't you mean PGC? Is it player generated content? Or am I making my acronyms wrong? Oh, procedurally generated content. Got it. There we go. Yeah, that's the one. Yeah, PropGen is cool. You just gotta make sure things are not all samey. But you can really make a lot of fun games with that. Right, so we're doing this. We need to write back into the node. How do we get our node? Okay, so the way we get this node is we need to edit it now. So you don't have pointers in shaders, so you basically just have to refer to stuff. Like we can technically have logical pointers, and we could probably do physical pointers if we want to restrict ourselves heavily. But for now, in the meantime, you just have to express it manually, and the compiler will just sort it all out. Because the optimizers they use nowadays on GPUs are pretty good. So we're trying to say the sphere's start index is equal to, like, so if you manage to load that out, you need to basically do a compare and exchange. Oh, it's a bugger. No. How are we going to do this? So it needs to be Project seems to work the best when it's hand author content. Yeah, I guess I guess that's what at the end of the day something's got to be hand done. But yeah, I see what you're saying, like when it's leaning more towards the hand done authored content first, right? Like we have like these big building blocks which are hand authored and they're sort of stitched together. So we then need to get our next right. So our next three, we're just do the bump allocator in this case. So just simply bump allocates. So that'll just be in the globals data structure. We'll just bump allocate this guy. We're gonna bump 8 because that's so many spheres per. No, I need to have good numbers or good constants rather. Right, so just bump allocate that. Then that'll get your next free index. Bear in mind, that has to be divided by That'll be fine. Um, so, given your free index now, it is actually in a place. Where is it at? Free list next in the volume spheres. So where's the volume spheres? So volume spheres, free index. Scale it by 8. Think. Scale it by 8. Fish out this next free index. It's not going to be atomic. Atomic though. Oh my days. Or it's a bit set, or it's bit filled, so you can't atomically address it. And the chances are it is going to be accessed across different compute units. So the caches will need to be synced. The atomics would do that. Whereas if you don't have them, it won't do it. So where are we going to stick? Like, so you've got your so you're just allocating them in this shader. The next shader that's going to run is probably going to go refine some of these. So it's going to take it's going to basically free some of these back. And the free list makes it so it's basically there's no extra storage to know where the free items are. Or the other way of doing it is basically like the one that's at the back of the array, or the one that's most recently been allocated, needs to get sort of patched, if we will. Wait, where's that? Right, then you want to copy. Anyway, do that in a sec. So it's as if you would then like patch. Like, if you were to free this back, and it was not the one at the end of at the end, you would somehow know how to find the one which has the end allocation and patch it. Um, um, well, the index could sit in the volumes. The volume nodes. No, because those get allocated at different times as well. Hmm. Yes, the biggest problem is just trying to get a free list. We need 10 bits. Because 10 bits will take us to 0 to 1024. That's another reason why to have a limit of 1024 actually is this thing. You've only got 2 bits left over after this. But given a volume sphere, it belongs to a cluster, and that cluster you know where it starts at anyway. So realistically, all we need is a 2. Oh my days. The savings. All we need is 2 bits. So then this means this can just get heavily reduced. But that's kind of cool and everything, but we're really just going to be wasting 32 bits on a free list next index when only one of them actually needs it. Yes, I'm good. Let's delete it. So unused then is what then? So you got 6 plus 3, so you got 9. 9, 13, 15. So you got 17 unused bits there. Okay, that's interesting. It is this thing, isn't it? That's what we need. This one. Boom. So what do we want to... Yeah, so that can literally just be 1U32, which would be pretty great, because this thing, like, even if we can make it fit into 2 bytes, which we can at the moment, I think, that would be killer, because this is going to be probably the thing that's allocated the most. Like, because if you have a volume, which is 1024 cubed, that's one gigabyte at minimum. So we're not allocating that many spheres. I wouldn't worry about it. But we'll probably be doing it in 512 cubed volumes potentially. I've still got to figure this one out. So if we're allocating that many spheres, oh my days. Trying it. Yeah, so within that many spheres, if you times that by 2 bytes, it's not as bad. That's 256 megs of memory of spheres before we simplify it, right? And then we simplify it and then it just goes down to something that's like very minimal. But yeah, we need this memory sort of allocated from when we build the very unoptimized version of it. So yeah, if it's 2 bytes, that's half 4 bytes. That'd be amazing. So maybe we can pack it down. So the problem is where we're storing this free list information, and in that case, we might as well have an array, right? Kind of annoying, but we might as well have an array where you just go given the like it's more likely to... So at the start, it's more likely to be like this. When the system's been running for a bit, I guess we can restart it all the time. We could just do that by default. Oh no. No, this would be, you can't reset anything. Oh. Uh, I'm not sure, Sleep Mushroom. I'm not sure you could be more safe with memory allocation. I'm not sure what you mean. Like, I don't know how C++ really helps with much. Um, yeah, so might as well have a buffer where we keep a free list. And we'll just push and pop on that buffer. Um, it would be super nice if we cram these into 2 bytes. Big savings. Where leaks happen. I don't know. Well, because you get destructors. Like, hmm. I don't know. Destructors are just magic that just happen without you knowing. That's the biggest problem. The biggest problem with C++ is it's full of implicit stuff where you just, you got to look at the code and you can't just look at the code and be like, that's what happens. You got to look at the code, know what types they are, and you have to actually understand what types they are because people can probably stick auto anywhere, and then you don't know what the types are. And then types have destructors and constructors, and then there's inheritance, and then there's a whole slew of things that can just happen implicitly. Oh yeah, and operator overloading as well. Like it's difficult to really read C++ code. Um, but yeah. Right, so we'll probably just have a buffer of there'll be a free list. It might be some free. Um, free indices cursor. So you have an array. And you probably just want to have or free indices stack count, something like that. So it's just a stack. So whenever you want to allocate from these, you've basically got a ah, Paz Penny Kids, thank you so much for the raid. Appreciate it. How you been? How's the stream go? Welcome, Raiders. How we doing? Awesome. Thank you, Moth Milk. Appreciate it. What are you going on to see yourself? Nice. Cool. How long have you been programming for? What sort of experience do you have? And do you have any sort of things you're currently doing to learn C? How did the stream go? Power Spinning Kids. Okay, so got this free index. So given this, like, so if it's a non-zero value, um, if it's a non-zero value, we bump allocate. If it is a zero value, we basically want to look in some volumes, spheres, free indices, buffer, and we've got to like, so this is where we've got to do like a wall leaf or something like that. It's really silly. And we've got to do some form of like, compare and exchange of some kind, right? Condition, value, something like that. So you compare and exchange. So how does the compare and exchange work on GPU? So you got the pointer to the value you want to compare and exchange from. You give it what you expect it to be. No, I don't get this. Spear V, let's take a gander. No, the spec. Hey there, Olin. Welcome. I'm going to major in computer engineering in the fall. I'm only 2 weeks in C programming, but I was in embedded systems and learned about kernel development. Oh wow, that's really cool. Yes, that's something I would have wanted to do in another life, you know. Yeah, I got interested in making games and stuff like that, and engine development. That's really cool. I'm glad there's people that want to learn how to make computers rather than using web browsers and stuff like that, right? Nothing relevant was digging into details of C++ standard today, mostly undefined behavior and type punning. Lovely. Yes. The complications of C++. What is going on? What's going on? Perform the following steps atomically with respect to other... Right, okay. Load the pointer. load through the pointer to get the original value, get the new value from value, only if... Oh, what have I done? Did I write this wrong? What have I done in my compiler to... So in here, I've done condition, whereas it must be equal to that value, then if not, set it to that. Right, expected, and then that's the value you replace it with. Right, got it, got it, got it, got it, got it. Okay, so compare and exchange. And what's the return type? What's the return? Well, let's guess what GLSL says. Function returns the original content. Okay, the original content. Right. So what it was before, we might not really care about. Wait, the original content? Regardless of the outcome. How do you know if it's swapped then? Is there no way to tell? Because on CPU you can tell. You get Boolean back. But I guess you gotta manually do that? You gotta be like... Okay, OG. So, this is what I expect it to be. And then what I want it to be is one less than that. This is only providing you free index. And we'll just do this afterwards. Right, so if the OG value... No, but how do you know if it set it? That's what I don't get. So you're saying this thing... performs a comparison with the compare with the contents of mem. If mem is equal to compare, then the data is written to, otherwise it's unmodified. The function returns the original content of memory regardless of the outcome. Right, so you can at least update it to the new... It says the original content. So that's before you overwritten it, right? Overwrite it, right? The contents of the memory being updated by this operation are guaranteed not to be modified by any other assignment or between the original value. This feels like it's impossible to work with. Like how? What am I not understanding? Like, what about an HLSL? Original value comes back out, so that's our return value. Like, I feel like the whole point of compare and exchange is so you know if you did it or not. I don't understand it. Atomic compares value referenced. Yeah, compare value stores and location. If it's a match, returns the original value of this. Okay, this operation can only be performed. Yep, units or ints. Hmm. I don't get this. So you'll get the original value back. Maybe that's all you need. Yeah, but the thing is you get the original value back and not the one that you modified it with. So you maybe loop round an extra time. I think that's the only problem with it. But you might have to do another load afterwards. It's weird. Like, so see, I wonder what you can do. If you start the free list index off as zero. Right, so if you start the free list index off as zero, you want to compare and exchange with the count, and you're saying doesn't make any sense. So pins makes it more elegant there, but maybe not. Because then that would get updated. Like if it was equal to zero, set it to, you know, E32 max. That's not good in that case. But for the other cases, it's, you know, but if it's not equal to zero, yeah. I'm trying to minimize the amount of branches here. So if it's non-zero, so you load it, it's non-zero, then it's going to be the original value when it did the compare, and you don't know whether it got it right or not, so you have to do another load. That just feels so dodgy to me. I must be misunderstanding something. Um, so this one's doing it on an image, and it's only expected to be zero, put one in there. And if it has zero. Yeah, so I'm trying to use it to decrement. Yeah, I think there's a way to do it where we just basically know the size of the array and decrement it, and if we're, you know, if we underflow, we can sort of we're out of bounds still and add it back or something like that. Yeah. Anyway, yeah, stuff to finish off here and get this working good, but we've nearly got this shader written out now, which is good. So after this shader's done where we construct all the leaf spheres, there's technically another shader we could do where we want to do some refining. But we could give it a test. I have to think about it whether we want to give it a test first, or do we want to do the refining? Yeah, it's kind of difficult. It's kind of complicated shader. But yeah. Right, I need to bust a move, but our next be on, what's the sort of dates we got here? Our next be on Thursday at 7:30 p.m. GMT. So basically in 2 days time, take 3 hours back. That's when I'll be on. Right, let's find someone to raid. Thank you for coming, everybody. Oh, no worries. Thank you for coming, though. Let's see if there's anyone programming in something kind of low level, I guess. Hard to find nowadays. No worries. Thank you. Thank you. Man, I'm so tired. So tired. Operating system stuff. Here we go. Right. Have a good center half of your week, everyone. I'll see you all in a future stream. I'm just gonna go eat some food and then just crash on the bed, you know. Oh, so knackered. But yeah, have a good one, guys. Catch you later.